All right, for 2.5 part 2, we're going to pick up right where we left off at part 1. And we're going to start off with an important concept. Basically, if you're doing either long division or synthetic division with polynomials, and you end up with an answer that has no remainder, then basically you factored that polynomial. And I'll give you an example to show you what I mean. So let's say we're doing this division question right here, x cubed plus 5x squared minus x minus 21 divided by x plus 3. And you either do long division or synthetic division, either one, and the answer comes out to x squared plus 2x minus 7 with no remainder, and that part is important. Now let me show you what's happening here. I'm going to show you with just numbers because I think it'll make sense to you guys. If I said something like 20 divided by 5 equals 4, which is obviously true, if you worked it backwards, you could say 4 times 5 equals 20, which is also true. And that's what we're doing here. Once we've done the polynomial division, this one here, the x plus 3, times this one here, the answer, will end up equaling the original polynomial. Now, if you write that out, you can see it's actually in factored form. It looks like this. So our original polynomial that we're dividing, x cubed plus 5x squared minus x minus 21, ends up equaling the answer to the question, which was x squared plus 2x minus 7, times what we were dividing by, which is x plus 3, and that's factored. So in this red box here, this is our key concept for this section, and this is how we're going to factor polynomials. Now I said using synthetic division. You could use long division, but I think we're going to use synthetic more often. But basically, if you divide polynomials and the remainder is 0, then you found both a factor and a solution, which are essentially the same thing. So if you use synthetic division, then that number x equals c is a 0, and the factor that goes with it, which is change the sign x minus c, is a factor. So if we combine that with what we did in part 1, here's our steps for finding zeros. Step 1, we're going to do the rational zero test from part 1 and make a list of possible zeros. Now step 2, we're going to test them using kind of a guess and check synthetic division approach. Now when I say guess and check, what I mean is we're going to pick numbers from our list of possible zeros. We're going to try synthetic division. If you get a 0 for the remainder, then you found one of the solutions and also one of the factors. Now if you don't get a 0, if you get any other number for the remainder, what that means is the number that you are checking is not a 0, not a solution. Throw it out and test another one. Now our goal is to get down to a quadratic, a second degree polynomial, because we already know how to factor those or how to solve those using quadratic formula. So basically, the bigger the polynomial is, the more often you have to do synthetic division. If you end up with if you start with an x cubed function, you only have to do synthetic division once and you're down to x squared, and you can do it the old-fashioned way. But if you start with x to the 7th power, you have to do synthetic division 5 times, because each time you're dropping by 1 power, x to the 7th, 6th, 5th, 4th. You got to get all the way down to x squared, and then we know how to deal with that. And then once you have the x squared, you solve it. And you can either factor it if it's factorable, or you can use the quadratic formula. Now I will say up here, when I said guess and check right here, we talked about in part 1 how you can use graphs to kind of avoid the guess part and just skip straight to the check. And we'll go over that in the first example here. So here's our example. We're going to find all rational zeros. So for right now, we're not worried about any complex zeros or any irrationals like square roots. We're looking for just rational answers. So we want to find all rational zeros of this polynomial right here. And what I'm going to do is I'm going to start with the rational zero test, which we did in part 1. So the rational zero test says I'm going to make a list out of the numerator is going to be every possible factor of 30, and there's a lot of them. over every possible factor of, now this is basically a 1x squared right here. And that's good. If you have or x cubed, not x squared. If your lead coefficient is 1, it means there's no fraction answer. So we have only whole number answers, which is pretty good, but we have a lot of them. Our possible zeros are plus or minus 1, 2, 3, not 4, 5, 6, not 7, 8, not 9, we have 10, we have 15, plus or minus on all of these, and we have 30. So that's kind of a long list. And when we go to set up our guess and check, let's do that. So we're going to set up for synthetic division. I have 1x cubed, 4x squared, I have negative 11x, and I have negative 30. Now what I could do is just start guessing. I could say, well, let's try the positive 1, and if it works, great, we're done. Or if not, try the negative 1, and we could keep going and going and guessing. But what I want to do instead is I want to go back to Desmos, graph this, get an idea of what our answers are. So remember, we talked in part 1, if you can see the graph, the x-intercepts are the answers that we're looking for. So let's do that. All right, so let's go ahead and take a look at this graph in Desmos. So I opened up the Desmos graphing calculator, and I'm going to type in my equation, which is x cubed plus 4x squared minus 11x minus 30. Now remember, you can zoom in and zoom out if you want to get a better view. This is what our graph looks like, but remember, I would probably zoom in because what we're really looking for is the x-intercepts. So that's a good look at the x-intercepts right there. And basically what we have is it looks like negative 5, negative 2, and positive 3. Now remember, all three of those numbers were on our list of possible rational zeros. Now without doing the guesswork, I think we found them. Just remember, that's not enough. We still need to go back and do the synthetic division work because that's what actually showed. This is kind of an estimation, but by doing the synthetic division work, we'll have shown that those are the answers. So from Desmos, the ones on this list over here that we think are the actual solutions are negative 5, negative 2, and positive 3. And remember, those are all on the list. We have the 5, the 2, and the 3 were all from our list. But see, now we don't have to do as much guessing. Like I probably would have tried the 1 first and it didn't work, and tried the 2 first or second or whatever. You don't have to do any guessing. You can just try the ones that we know work. So you can put any one of those 3 in. I'm going to do the negative 5. And here is our question, by the way. So and then here's the synthetic division from last week. The first number, the 1, drops down, and then it's multiply, add across. So negative 5 times 1 is negative 5. Add is negative 1. Negative 5 times negative 1 is positive 5. Add is negative 6. Negative 5 times negative 6 is positive 30. And then negative 30 and 30 gives you 0. And remember, that's what you're looking for. You have to have a remainder of 0 or you didn't find a factor. If I got a number other than 0, then I would have to try something else. So the negative 5 worked, even though we knew it was going to from our graph. And now you have 2 choices. What you can do, and what I would normally suggest, is you just rewrite what's left over as a quadratic and factor it the old-fashioned way. So basically, and I'm going to leave the bottom blank, so I'm going to come back and show you something else we could do here. That 1, negative 1, and negative 6, we've gone from x cubed to x squared. So that represents 1x squared minus 1x minus 6. And see, that you can factor like we did earlier on. You're just looking for 2 numbers that multiply together to give you negative 6 and add up to give you negative 1. That would be negative 3 and positive 2. And then by switching the signs, you get positive 3 and negative 2 for your solutions. So we did find the three answers that way. The -5 we factored out using synthetic division. That's one of our solutions, or one of our rational zeros. The other two we got by factoring the x squared minus x minus 6. Now I said, I'm going to go halfway back in the question. Because we used Desmos and we already knew what the answers were, you don't actually have to stop at a quadratic. You can keep going here with synthetic. You can just like make a chain out of your work. Just continue your work there. So let's say after the -5, I said, well, I want to do the -2 next. So I dropped down the 1. -2 times 1 is -2. Add is -3. -2 times -3 is +6. Add, you get the 0. And we just found our second answer. And then you could really even just finish it. You put the +3 here, drop down the 1. 3 times 1 is 3. Add is 0. So you could have found that you can use synthetic division all the way to the end. If you have a pretty good idea, if you've seen the graph and you have a pretty good idea of what the answers are, that's probably the best way to go. But if you don't have the graph and you're guessing, and you remember we had like 16 numbers on our original list, we don't want to go through and guess each one of them. So if you're guessing, it's probably best to just get as few as you need and then solve it as a quadratic like we did over here.